All right. Hello, everyone. Let's get started. So, today we're going to cover three quite interesting design patterns. And that is state, bridge, and null object design patterns. We will try to understand how does state pattern help us manage dynamically changing behavior of an object based on its internal state. How does state compare to strategy? How can we utilize polymorphism in fighting null reference exceptions? And therefore we'll learn null object pattern. We'll also learn bridge. And how is that related to managing a change when change can happen for implementations and for abstractions independently? And lastly, we'll talk about how does bridge and composition and facade compares. Hello. So let's start with state machine, or how to battle if statements based on internal state. State, I actually should not say state machine because I don't yet want to talk about that. We're gonna talk about state. It's quite important not to mix those two because state and state machine are two different things. State is a design pattern. State machine is a structure, is an object that can be used to set up how the transition between states are, but not necessarily manage it internally. So state is much more, how to say, it's much more abstracted away. Like state is self sustaining, and it's split into many state objects. And state machine is more, you set it up externally, and there is no concept of state itself. You just set up transitions and what happens when a transition happens. So state is a behavioral design pattern. Sorry. And the gist of it is that when the state of an object changes, its behavior changes as well. So here is the problem that you might have with state machine. If you have a bunch of, a complex subject state like snacks machine, and you notice the problem with this code is that every single method is based on has some if statement, and every method will have an if statement. If you are trying to do something, you always double check what state the machine is in. And actually the state itself is defined by multiple variables, not just one. So it's quite complex, and imagine that it can grow out of control. So what problem does state machine solve? Again, not state machine, but state. I use it interchangeably, though it shouldn't be used like that. So state solves many if statements problem. Across different methods, you have many if statements. That's a problem. And state machine solves that through polymorphic behavior. And this is how a state diagram for vending machine looks like. So, you start vending machine filled, it's ready for selection to be made. So user enters some code of merchant of a snack, and he makes a selection. So selection made signals to state that, hey, is there any snacks available? And if it's not, you get rejected and you're back to ready. If there are snacks available, you're asked to pay money. So money paid um, is a state when you paid money. So selection made is a state when you are required to pay money or go back to ready immediately. And money paid is a state when you actually paid money and the state machine is ejecting a snack. So after you paid money, you can, take the snack out. And after you took the snack out, the machine, if it's empty, it becomes sold out. So it goes hibernate mode. And if it's not sold out, you will go back to ready. Like another person can make its own order. And of course, if you refill the machine again, it goes back to ready again. And in a class diagram, it looks like this. And the key point here is that in every state, all of those five methods, sorry, are blocked. Invalid methods are blocked. You don't let those through. You might wonder, that looks like some sort of complexity. Why would I want, state? Why can't I just do it, in one class? But then when you think about it, if refilling changes, the same place changes. If eject changes, the same place changes. If payment, the way you accept payment changes. Again, there are too many reasons for a class to change, and therefore it should be split. Now, if I split it across states, only if that state, the things that impact that state change, only that part changes. So it's all nicely encapsulated. And the snacks machine itself acts just as a place that manages transition between different states. That's its only responsibility. Now, state machine might look kind of like strategy. Strategy is much more simple though, and the difference between not state machine, but state and strategy is that state is based on, object state, obviously. Strategy doesn't have to be based on anything and usually isn't based on anything. And actually, strategy usually takes input and does something with it. And it's also usually responsible for a single behavior as opposed to state, which usually solves a problem of if statements all across different methods in the same class. So that's quite a different thing. State is dynamic based on a changing state of an object. The state will change. However, strategy is not going to change as much. Usually you simply inject it and throughout the application lifetime, the same strategy will be used. So that is the difference between the two. And I'd say that strategy is more often used, but state has some merit and solves some problems. And it's definitely a pattern that you should not uh, look down upon. State machine, though, is basically a way of managing state externally through a monolithic way. And this is an implementation of a state machine in .NET. As you can see, there is a stateless, that's the library name, which allows us to configure a state machine through Fluent API, like so. But I will not talk about this, and actually I'll try to do a special lesson where we delve deep into this, and we'll try to redo our vending machine implementation through state machine. Do you guys have any questions if you were following so far, and what do you think about state? Have you ever had a problem of many if statements? How did you solve that problem? All right, enough for a break. Let's move on to bridge. What does bridge help us do, and what kind of pattern that is? So bridge is a structural design pattern, and that should suggest us that it solves a problem of too many classes or something maybe being too poorly organized. So if there is a large class or many classes, it helps us separate the hierarchies of those classes into two: the implementations and the abstractions. And this might sound awfully weird, but abstraction doesn't really mean an abstraction. I would say a better word would be it allows us to split classes into high level and low level. And what does that even mean, you might wonder? So imagine this. You have a shape class, and there are a bunch of different shape classes that through polymorphism will implement how it's being rendered, drawn on the screen. So you have red circle, blue circle, green circle. You have red square, blue square, and green square. And this might look maybe okay, but think about it. There are two colors, there are two shapes, actual shapes, and three colors. So however, we have 6 classes, and actually, if we introduce one more shape, we will now have 9 classes. If we introduce one more color and one more shape again, we'll have 16 classes. So that's a problem. However, the solution is bridge, separation. So instead of, now having 6 classes, we suddenly have only 5. And in the scenario where you would have, 4 shapes and 4 colors, it wouldn't be 16 classes that you would need to combo. It will be just 8 in this case. So you can see a clear problem and a clear solution to that problem. Class explosion being solved by bridge. And why is the name bridge for this? Look how this class relation, this whole diagram looks like. You see these this relationship looks like legs of a bridge, like the interface is being supported by the implementation. So on the left side, on the right side, it's literally a bridge. And here is a road where one abstraction goes to another abstraction. Well, where abstraction goes to implementer. This is not really an implementer. I would say this is just details provider. So shape has a color. It gets color here, like so. Not the greatest example still, but it illustrates how a problem could be solved. And lastly, we have NullObject, which basically allows us to battle null reference exception through polymorphic behavior. So imagine that if we could define what happens when an object is null through another object, which has neutral behavior. So in that null object, we define neutral behavior, and neutral behavior in most cases is either, empty, does nothing, or maybe has a default value. So the benefit of that is that we don't really need to handle null reference explicitly from the outside. It's handled through polymorphic behavior, which is much, much more convenient and neat to work with. So a decent example of this would be, imagine that instead of, returning returning people and their information of their employment, your position, your employment instead of null when you're unemployed, you would literally have an object that says unemployed, null object. And sorry, that's supposed to be unemployed, not nothing. So that object name value would not be null, but it would be unemployed. So instead of position for a person, you would have unemployed. Now let's go to code part and try to create a snacks state machine. Actually, let's start from the employee. And before we start, please let me know if you have any questions. I'll go quickly with the example. So we have person and we have employment. So person has what? Public string name, let's say. And person also has public string employment. Yeah, employment it has. And I want to, you know, have a person like so, quite simple. And the employment itself, it has a name. What else does it have? It has salary. Decimal, of course. Oh god, I hate when they do it like this. So that is it. And lastly, we have this. So that's our employment, right? What if we have that? So, okay, let's play with employment, okay? Let's have an example, okay? So when we create a person by default, it might not have an employment, right? So employment will be null, undefined. And it can change over time, that's obvious. So if I have a person and I give it a name, let's say Thomas, and I say, hey Thomas, give me your employment details, and actually I'd like to know about the name of your employment. So I will print it. Because it's a string. Sorry, it's not supposed to be string, it's supposed to be employment. Okay. So hey Thomas, give me your employment details, and specifically I'd like to know name and, you know, the usual stuff. Name and how much you earn. That's all I want to know. Your position and how much you earn. And obviously you might expect already what will happen. Brackets missing. So the thing that will happen now. Oh my god. Those are not good Java design patterns. Out! Employee demo. Person employment demo. Let me fix one thing. Okay, This is good. So person, employment, demo, run. So now we have basically a person called Donut, and Donut is unemployed, and unemployment is defined through if you're null, you're unemployed. So your employment is null. So when I try to access the name of your employment, it will throw me a null reference exception. So if I run, you can see null reference exception. How can we fix that? And the fix is very easy. So next to our employment, we will have unemployed class, which has a constructor that sets default values to salary and name. So the salary is obviously, well, the name is unemployed and salary is 0. That's it. So now if I go back to person, when I create a new person, and here I pass in, a name of a person, now I will instead set employment to unemployed, because that's the default object that we will use, and basically this object provides us default values. So if I go back to program and run it again, you can now see that Donut indeed is unemployed and he earns 0 due to being unemployed. I should slightly improve the demo so that makes a little bit more sense. And let's create second person who actually has employment. New employment, teacher, salary 1, underpaid, Donut, Heisenel. Okay, so Donut is earning this much, Heisenel is earning this much, and if we run now, we can see Heisenel, that Donut is unemployed, earns 0. Heisenel is that. But if you want to check if one is unemployed, well, if I would want to check that, probably, I mean, if I wanted really to check that, I could check the type. Employment abstract. No, I shouldn't make employment abstract, I think. Because I don't want subclasses to be made, so it doesn't make sense to me. But if you want to check if one is unemployed by accidentally creating an instance of employed and just write unemployed. I mean, I could. I don't know if it's worth it. It's overkill right now. I could write something like this. That would do the validation. name, salary, and this would mean if salary is 0, row new exception must, well, more than 0, less than 0, less equal than 0, must be earning money. So now you cannot make mistakes. And if I make this abstract, that's good. So yeah, this kind of protects against you entering 0 or negative. So if I go back to the demo, yeah. Why not? It's better, and yeah, let me know why not. Now employed has a link to unemployed. No, employed has no link with unemployed. What do you mean? There is no link between the two. It has a link to employment. It's not aware of unemployed existing. What do you mean? There is no logical connection. Unemployed connects to employment, but not the employed. Where is the logical connection? Could you please be specific? Code-wise? Which subclass knows about the implementation of another subclass? Could you please be specific, because you don't make sense? There is, okay, there is this subclass, employed, right? And then there is this subclass, unemployed. These two classes don't know about each other. They only know about employment, right? So they are not aware of one another. I can remove unemployed and nothing would change, so. This stands for inheritance. So I'm saying that unemployed inherits employment. Okay. You mean here? Obviously here it makes sense to check this because I don't want an employed person to be earning 0, but this has nothing to do with unemployed. It's not related. What makes this related to unemployed class? It has nothing to do with an unemployed class. I mean, employed person must be earning money. I don't hear anything about anything about unemployed person in this description, this if statement. It's just about salary, and employed person must be earning money. Otherwise, he's unemployed. I said unemployed, and therefore I am you know, checking that thing here. And either way, I would love to know what suggestion do you have how to make this better, avoiding this issue. Okay, you're trolling. State pattern solves the problem of many if statements. It doesn't solve a problem of that single if statement. It's one if statement. That's a completely different problem. And there is no coupling between classes, and you're just making up excuses. All right, let's go on with the next example. So the next example is bridge. And we will say shapes example. We'll have a shape and we will have a color. Actually, I won't have color. Color is already there. So I'll just have shape. Shape is abstract class. Nah, shape is actually an interface. It's better. It's too simple. It just needs to implement draw method. And we have a bunch of shapes. Let's say 2 shapes, right? So we have a shape called rectangle. This doesn't really show the problem though. Okay, so I will have, doesn't show the problem. Okay, so instead of shapes, we'll have moving shapes, right? iMoving shape. So iMoving shape, it can be rendered and, well, drawn is good enough, and it can also move, let's say, somewhere, somehow, I don't care. And we have a bunch of shapes like rectangle. And circle. So we have those 2 shapes, and those 2 shapes can move differently. How does so what could move shapes? Oh, I know. Not moving, but animate. Animate sounds much better. Animated shape, not moving shape, sounds much better. So we have shapes and we have animations. Void animate. shape. I'll change slightly things. Oh shit. And I'll call it draw. And another one. Animated shape. Is eye shape, eye animation. I don't have eye animation? Fuck. Eye shape. Eye animated shape. Okay. Oh shit. Eye animation. Okay. Animate. Okay. We animate eye shape. Shape. Okay. It's fine. This is good. Eye animation. Good stuff. Good stuff. So circle, not any circle, it's animated circle. Right, this is good. Okay, so we have animated circle and animated shape. It's good. And then we have animated rectangle. Animated rectangle. Good. So basically, circle. So basically what I would like to have now, so I'll split this into shapes and animations. Boom. Okay, this is good, this is bad. It's good, good. This is animation. So I mixed up names. This is good. This is shape, mixed up names. Good, you go there, you go there. Now I need to create a bunch of animations. But before I do that, I'll just make sure I have implemented how I draw a rectangle. Private const int. I don't care about the size to be configurable. I think this is okay. Size. Let's say it's 2 by 2. Actually, I won't have a size. Instead, I'll have the whole shape because I don't want to be bothered by making that. Drawing, I guess. So how does a rectangle look like? Something like this, I reckon. Shit. That'll do. There probably is a better symbol, but I don't know which one it is. I don't want to be bothered. I don't care either. Actually, it's a rectangle, so it's okay. It could work out. And obviously I want those in new lines. Why not? Oh, right, it's not constant. Read only then. Okay, this is good, this is good. That's not needed, and boom, done. That's the drawing. Now, how do I animate it? I don't know yet. Probably I cannot animate multiple shapes, but probably I don't care either. One will do for now. So if I go with rectangle and say draw, nothing happens because I'm not running the demo. Okay. So we go and say shapes example run. Boom. We have a rectangle drawn. Now, how do we animate it? Let's create an animator. I mean animation. So what animations do we want? Move left. Move right, I mean. I don't like what I see. Be right back, 1 minute. Hello, now I am. I was in the bathroom. Okay. How do I animate? How do I animate? Move right. How do I animate to move right? I need to shift everything, all symbols to the right. How do I do that? I need to know what I have. I cannot read the console, but I could read the shape. I could read the map. I don't care about the map. I could move everything to the right. So I could clear and print it, shift it. Okay, I gotta do that. So drawing will work slightly different. I know it's not best, but in the little time we have, I cannot think of anything better. The necessary evil. Shit. Animate doesn't need to be one. It's good, it's good. This is good. So move right. How do I implement move right? Move right is animation. And what do I animate? I animate a shape. How does that work? Basically say shape, draw. Oh, okay, I know what to do. I know what to do. I'll change it. Let it be void again. Yes. This is good. And shape itself, it will have void string. It will have the pattern it draws, you know. Pattern itself. This is good. Okay, so circle. What pattern does circle have? I don't know yet. However, rectangle, we know what pattern it has. And that pattern is here. Good. So that's the rectangle pattern. That's what I do when I draw, and when I animate, I actually do this. So move right animation does this. From my shape, I get the pattern. And what I want to do now, I want to shift everything to the right. How do I shift everything to the right? I want to first split the whole string by lines. So I can, you know, do I want to do that? Yeah, I do want to do that. So I want to split the whole string lines. That's the pattern. Split by a and by environment new line. So I get my lines. When I have my lines, I can do the thing and say for each line print the thing shifted. And that's quite simple. But remember the last thing. Shit. Yeah, remember the last thing. I don't like this. Actually, I don't mind this. String pattern. Not very clean, definitely not very clean, but I won't refactor. Oh, not pattern. Last drawn. Yeah, that's good. That's good. That's good. That's good. That's good. Shit. Okay. It should be dedicated for the shape. Yeah, so I don't need shape itself. It can be more abstract. Okay, good, great, awesome. Awesome. This is good. Good shit. So move right and last drawn works pretty well. Move right. Last drawn is the shape that we pass. We get it from the shape. Shape.pattern. Awesome. And our animate now works like so. That's good shit. And it's not read-only, of course. No, it cannot be made read-only. And I don't want to print it like this. I want to literally shift it. So I want a string builder probably. Actually, it's not overkill if it's longer. So I'll use it and I'll say SB add append line. So I'll be appending lines instead of printing lines. Yes, please. Good shit. And finally, last drawn will be equal to SB to string. And I'll print this last drawn thing. Awesome. So it should move right. And it should do this asynchronously, maybe. It doesn't matter. It doesn't have to be asynchronous. I'll make it asynchronous from somewhere else. Good stuff. Okay. So if I go here, not needed, not needed. Oh, no. Good. Awesome. Awesome. Everything is great. Great stuff. What am I missing? So now I would like to go to animated circle. No, to animated rectangle. And say that public I animated rectangle is created by adding it a animation. Okay. What's wrong? Animated shape. I want animation, not the shape. Cool. So we have animation and animate will be just that. I mean, make it an expression. Yeah, make this also an expression. So the whole point why I'm doing this is that imagine that you have 10 shapes and 10 animations. That would mean you would have 100 different classes that implement how different shapes move. But if I, abstract away the animation itself, I'll only need 20 classes instead of 100. So it's a plus instead of a multiplication symbol. So, right. So how do I move? All I need now is a delay. Fuck, I don't want to do that. It's gonna hurt the CPU. I async animation. That is task animate. Cool stuff. Right, this is good. Going back, async task, and I'll expand. I don't care. Good. Okay. So what do I do? Let's say we have duration, right? How long will the animation run? How fast it will run? And float, interval. Float, length, duration. And we say while var left duration. Obviously I need to set those. Private read only float interval. Private read only float duration. Interval is interval, duration is duration. And here I say left is duration. And here I say while left is more than 0, I do this task dot delay. And the delay is interval. Which is supposed to be, okay, I'll change these into, fuck, I need to use int. So all of it is in milliseconds, obviously. Left Interp. Okay. Looks good. I hate this because it'll be duplicated. So probably the animate shouldn't be a sync task. It should be just void, and animator should be something else altogether. Okay, anyways, let's see how it runs. Yeah. All right. I need animation, so move right. I need a shape, so rectangle. Okay, that's quite fucked up. Okay, I really hate this design. I hate this design. This is bad code. Okay, interval 100 milliseconds, duration for 5 seconds. And here say animation dot shit. Okay, cool. I'll go move right. Yeah, this is good. I mean, it's not very good, but this is okay. Nothing is happening. Let's have a sync task. A sync task. Await. Okay. Await. Okay, let's go. Oh shit. What did I fuck up? Last drawn. All right, line, not lines. Okay, it kind of works. Well, not really. I need to clear console every time. So now it should work. Amazing. Why is my cursor going down? I cannot tell. 0, 0. Why is my cursor going like that? Huh. I don't know. Oh, I think I know. Because every time I think I add one extra new line. Maybe. Maybe not. Maybe yes. I should trim, I think, in the end. Yeah. Okay, animate. Trim. There we go. Almost. What's up with the first line? How is the first line not shifted? Because I trimmed. Oh, okay. Trim end is what I wanted. Amazing. Amazing. Okay. Lastly, the thing I want to do is to have an animator. Then. So let's go back to this. This is ridiculous. Let's just keep it I animation. Let's go back here. Voiding. Is good. The rest is not. Okay, this is good. Why do you wanna pick on me? Oh shit. Yeah, because there is that shitty method that I don't care about. Fuck, this is so bad. This code is so bad. Uncalled for. Right. Let's have an animator. Public static public void animate, not void but async task. Action animate. Okay. Shit. Duration and interval. This is good actually. Int duration, int interval. Duration interval. Okay. Static. Task animate. Animate. Cannot have non-static. Static. Okay. Good shit. Remove those two because they're not needed. Good shit. And animate will do rectangle animate with 105 111. This is good. What? Like this, no? What? You don't take 3 arguments? Right. Animator. Animate. Okay. These two are not needed. Okay. Run. What the fuck? Why is it not animating? Is this being called multiple times? Once. Animator. Animate. Yeah. Huh? Wait, I deleted too many things. What the fuck? Do I have left? First has delay. Wait, there is so many. Mm. 5 seconds. 1, 2, 3, 4, 5. And okay. What's wrong with this method though? Does it change anything? Oh, what? Okay, I see. Shit. Shit. Okay, I see. Okay. Mm. Okay, so imagine if you had like more animations, move left, move right, up, down, and different shapes. So instead of having multiple animations, multiple shapes, with their own subclasses, now you just need the animation that you pass into a shape and it moves by itself. Again, not very practical to pattern. I wouldn't like to play more with it. Let's move on, because I already quite messed up how it works. Okay, anyways. So we have snacks machine, and it's hell of a snacks machine. So if selection has value, do you remember the diagram? Well, now let's create it. So snack itself has an ID. That's all it has. I don't care about the rest. Whoa, what did I do? Okay. Okay. Um, Actually, the best would be stack here. Stack? Dictionary? So what's the problem? I wanna pop the thing, out of my stack. But I don't want the top one. I just want the specific top one. Yeah, it's not very good. Not stack. Okay. It's gonna be more simple. Yeah, so how many snacks of that ID are left? That's the way it will work, basically. For clarity's sake, right, so snacks selection minus minus, and it doesn't work because it should be value, and I don't return anything. Well, I do return the snack. Fuck, the snack of that ID. I can return. It's not the same one. It's a function that creates snacks. Nah, it shouldn't really work that way. Okay, I'll return the same snack. I don't care. It's not gonna be eaten anyways. Okay. Yeah, let's return something ridiculous. So I'll just show some of the, pieces of this. So this is the first piece. So if we refer back to the state machine, you can see that money paid, snack ejected. So snack can only be ejected when money paid. So it's not only selection, but also current pay is equal to equal more or equal to snack. All right, so we first look up the snack itself. Which already is becoming quite money. Fuck. Current pay more than snack price. Decimal price. Price. Okay. Yeah, you can see that it's not very pretty code now without state pattern. return, I forgot. Okay. Snack itself is gonna be shared. Let's paste. And let's have the base idea, basically. So the base idea is that when I make my selection, I don't care about anything here. All I care about is the state. snacks machine state. It's an interface, a public one that can eject a snack. That can what else could I do? Select something. Int ID. What else can we do? Hey, int money, let's say. I won't play with it that much. So we have those three, let's say. So private I state. Let's create a few implementations. Okay. Ready. Selection made. If I go here, my initial state is ready. When I eject the snack, I say eject, and then I do a switch, you know, but for simplicity's sake, I'll say that my state is again ready. When I make my selection, I say my state is selection made, and state is select. Say 1. And yeah. And last one, when I do what? Pay. Decimal money. State. Pay. Money. Let's call it quarters. State equals new money paid. So that's basically the idea of state. You see how more clear everything is? So how would money paid would look like? Well, this is not supported. This is not supported. This is also not supported. I mean, eject is supported. So you return a selected, item. So selected item. So decrement. Something like this. It's quite late for me, so I'll leave it here due to the lack of audience. So thank you guys for watching and see you next time.